You know that.
Just every time somebody walks away.
All right. Sorry about the whole pizza deal, everybody. They were just very busy, but now they finally delivered, and we just want to get started. Thank you very much to everybody for coming. Sorry again about the delay. Before we get started, just thank you very much for Luke coming out to be able to talk. Thanks to Invoca for hosting us and for the pizza. And then also, Jonah wanted to make a quick shout out. Jonah, come on down.
Hi, I'm Jonah. I'm a consultant in town, and I've had a private co-working space sharing with 4 other people, a photographer, a filmmaker, and an architect for the past 5 years. But that situation is changing. The landlord's going crazy. So I'm probably looking for a new workspace, office space, whether it's a shared space or whether it's a small office somewhere or something. So if any of you have a space or know of anything, talk to me afterwards.
Landlord going crazy in Santa Barbara. That never happens.
It's true.
So yeah, we have a Slack network that hopefully you can post on that. If anyone else wants to get on that, definitely connect with him and everyone else on there. We are usually at work zones, so next month if you want to come by, I think that's where we're going to be. But let's get right into it, and without further ado, here's Luke.
Cool. Hey everybody, I'm Luke Michals. I'm a front-end software engineer at Procore. And today I just want to talk about 2 of my favorite libraries, which are D3 and React. Okay, so to set some goals for this talk, I was hoping by the end of this, you'd all be able to answer these questions. Are you all good in the back? Can you see this? Sweet. Okay, so I would like everyone to be able to answer the questions of what is data visualization? How does D3 fit into the data visualization ecosystem? What can be built with D3? How does it work with React? And how should you approach a problem if you want to build a visualization in your React application or some other framework? Like how should you approach a general problem? And then stretch goal. I want everyone at the end of it to say, wow, like D3 is an awesome library. I'm super stoked. Like I really want to use it in my projects. Cool. So very general, broad definition of data visualization. The presentation of data in a pictorial or graphical format. Okay. So what I'd like to do is keep this definition in mind. But when you think about data visualization, don't just think about pie charts and bar charts and scatter plots and things like that. Data visualization is everywhere. So here's one of my favorite applications. It's the Spotify Electron app. And I'd like to play a little game of I Spy with everybody. So, there's going to be a little bit of interaction in this presentation. But like right now, like shout out, where you see little bits of data visualization.
Progress bar.
Progress bar. Beautiful.
Plus the check mark.
Plus and the check mark. Yeah, right there. There's a check mark, and here are pluses. So that means that, the check mark means that it's in my library. The plus means that it's not in my library just yet. Other ones. Album.
The music progress?
Yeah, progress bar right there.
Playlists on the left.
But yeah, volume is another slider there. Cool. I think that's good. So these are all the ones that I spotted. So just let's start from the top. Just the mere fact of graying out and disabling that forward button is a form of data visualization. It's like conveying that you can't go forward based off of dimming that button right there. What about this little dot right here next to my drop-down menu to tell me I have a notification? That's like a little micro data visualization right there. This speaker here means that my friend Brian is actually listening to his music. Looks like this means that he's playing a song, and Whitney is listening to an artist right here. Yeah, so just like the mere fact of turning the text green, meaning I'm currently playing that song. And you guys spotted the check mark. Yeah, the thumbs up. There's another one. Yeah, so again, maybe like a little goofy of an exercise, but just like, data visualization is more than just bar charts, pie charts, things like that. Cool. So this is a little activity we do in our squad called this of 5. So on a scale of like 5 being, I know this library inside and out, I could pretty much recreate it if I had to 1, I've like never heard of this library. I'd like everyone to throw up, somewhere one of those numbers on each of these libraries. So D3, this of 5. So I see 1, 3, 2, 1, 5. Nice. 2, 1, 2. Okay, 3. I'm averaging maybe like 2. Yeah, probably around 2. What about React? Same thing. 5. Beautiful. 4, 3, 3, 3, 3, 2. Okay, maybe like 3, 3.5. Not a library, but like SVG elements in the browser. 5, 2, 4, 3, 3, 3. Okay, like 3.5, 4. HTML5 canvas. 4, 4, 3. Okay, pretty familiar. And then this is CSS3, but what I really want to do is like animations. So like some form of animations or transitions in the browser. It's like 3, 5. Okay, pretty familiar with. And who's ever heard this phrase before? D3 doesn't play nicely with React. Show of hands. Okay, you have heard it before. Do you care to elaborate? Like why have you heard that D3 does not play nicely with React?
D3 has a lot of different parts of its library that manipulate the DOM, and if you mount it in the wrong way, React kind of gets its butt kicked.
Yeah, nice. Yeah, well put. Cool. So I'd like to not dispel this myth, but show ways that you won't run into that kind of problem. Cool. Who's used one of these libraries? Okay, I see 1, 2, 3, 4. Okay, a good amount of people. Anybody have any opinions on their experience with one of these libraries they want to share?
They're always limited.
Okay.
Like what you can do with them.
Which one have you used?
Chart.js is what I use.
Okay. What like do you have a situation that you ran into?
Not specific. I think I was trying to do like what was it, like a radio block graph or something like that.
Yeah.
And it was like, this is the style, this is what you're gonna use. Good luck adding any kind of picture to it.
Exactly. So that's the story that everyone will tell you on any of these libraries, right? So Tableau might be like the most famous, well-known one of these. Highcharts, Charts.js, Recharts. I've used all of them, and they all have the same problem, which is these are data visualization as a service, right? It's a full package that you can just feed in data and it'll spit out visualizations for you. But you're going to be limited on how you customize them, be it the color of the bars, or the number of ticks on the horizontal axis, or like how things transition, which is like how things change over time. You're just going to run out of customizability when using one of these libraries. And kind of like the nature of data visualization is it's tied very closely to the data that you're trying to display. And so people like really love to like customize these charts. And then you tell somebody that's who's not a developer or non-technical that oh, it just can't be done. Like they're tend not to like that kind of response. So that's when a library like D3 comes in. Okay, so yeah, here's another little activity that I wanted to do. So when I'm using a library, a node module, whatever you want to call it, I tend to think about it somewhere on a scale from library to framework. And so there's going to be a lot of subjectivity here, but let me give you Luke's definition of a library and a framework. So a library is a set of code that you use to help you along the way, whereas a framework is something that you build around or on top of. Okay, so based off of my very subjective definition of these two words, where would you say that a library like Lodash falls? You can point or like just shout out. Okay, very much on the left. I think, yeah, pretty much like the lowest level library you could possibly have, right? So Lodash is, providing very low-level helper functions to manipulate data in different ways. You're not going to be building, a web app around Lodash, right? Or on top of Lodash. What about Angular?
Right.
Yeah, very much right. You guys get how presentations work. So like, I'll do the other extreme of like, way over there. Yeah, it's like the most frameworky of the frameworks. It's like you follow Google Angular's conventions, and then you're able to theoretically build applications much quicker, etc. Yeah. Okay. What about jQuery? Where would you put jQuery on this scale?
It's more a library, but it can also be used a little bit more convenient as well, but still it's a library.
Yeah, I think I would agree completely. So I put jQuery like 25% of the way along the way, but I included this little bar here because you can use it in a lot of different ways, right? You can use it as that lowest level library like Lodash to do just like very small level DOM manipulation. If you want to select all divs of this class and then remove them from the DOM, right? That's low level, but then it has a little bit more like frameworky like features, like tying into document events and things like that. Okay, what about React? Where do you put React?
More of a framework, but it's still a...
Yeah. Okay. Yeah. So you guys see the big gap in the in the slide right there. Yeah. So I put it somewhere along the way. I included the slider bar there because if you pair it up with a library like Redux or MobX and React Router, and fill in the gaps of where React is missing, it can be a full-on framework. Okay. So now the big one. Okay, where would you put a library like D3?
100%, 0 to 100.
0 to 100. Yeah. Okay, I like it. Yeah. So I didn't quite go all the way to 100, but I went to like, 85 or something like that. Yeah, so this is the whole point of the slide. D3 is an incredibly versatile library. Kind of comparing apples and oranges, right? Like all the ones in the top here are like aimed at building user interfaces specifically. Whereas, well, I guess except for Lodash. But D3 is kind of like whatever, trying to do something different. But yeah, in the same vein, it can be used as like a very, very low level library where it has data manipulation helpers just like Lodash does. But then it can it does have lifecycle events, and it has, you can manipulate the DOM like jQuery, and it has lifecycle events like React does. So, it can be used on the more frameworky kind of side. So yeah, so what I wanted to get across, like compared to these kind of libraries, D3 is much more versatile. You can use it in a lot of different ways. I'd put all these libraries, way over on this side if we're talking just data visualization. And then because of the nature of data visualization, there's just like inflexibility that comes along with using these kind of libraries. Cool. Yeah, so let's explore a little bit about what you can build with D3. So I've frequented this site. If you guys have never been to it before, it's the Blocks website, bl.ocks.org. It's like the D3 hub where people will post their D3 visualizations. So this is specifically Mike Bostock's section or user page on the Blocks website. He's one of the founders of D3 or authors of D3, and I think by far the biggest single contributor. So I'll scroll through here. If you guys see something that catches your eye, definitely let me know and we can click into it. But I just wanted to show kind of the diversity of things that you can build with D3. Check out this Mona Lisa histogram. Okay, so this is displaying the distribution of RGB colors in this box. As I change. So if I go on her hair, it's going to be much darker, and then if I drag it on the yellow, it's going to be a lot different. And then they show the code down here on how he built it. So you can build something like that with D3, but at the same time, let's see what Force Dragon does. You can build little, I wouldn't even really call this a visualization. It's like a simulation, right? With some physics built into it that allows you to simulate what it's like to drag around some circles. Yeah, I think you guys get the idea. Oh, these blocks are pretty cool. Yeah. So like check like these polar fox with like, you know, just like, I don't know, D3 is awesome. You guys should check it out. Okay, cool. Yeah, so just to kind of compare and contrast D3 to a few libraries you're probably more familiar with. So I wanted to talk about jQuery first. So just, you know, very high level, very very coarse description of what jQuery does as a library. Ties into document events, does explicit DOM manipulation. You can, again, select elements by a specific class or ID name and remove them or change their background color, CSS attributes, etc. like that. Event handling, helper functions, if you want to tie into click events or hover events, things like that. And then do some like asynchronous JavaScript. And then on this side, you got React. So React has JSX, which is HTML inside of your JavaScript. It has the lifecycle methods, so you can see, you know, tie into when a component mounts or when it did mount, etc. Abstracted DOM manipulation, I would put in line with the diffing algorithm. I think you're all pretty familiar with React. And then state management, again, it's not like one of React's strongest suits, but when, you know, paired with something like Redux, it has a very strong state management. And look at that, Venn diagrams, right? Data visualization, yeah. So D3, like D3 kind of adds to the mix, like data loading helpers. This is like if you wanted to load a CSV file or something, you could load it into JavaScript. D3 has the helpers to parse through the CSV or TSV or, you know, whatever kind of data file you have. And then it has visualization helpers, which are specifically for like, you know, creating a bar chart or creating, sorry, I should say, like creating the like the path elements that then get turned into SVG elements that create a bar chart. And then like some overlap with some of these other libraries. So like the explicit DOM manipulation it shares with jQuery, or it also has lifecycle methods, albeit, you know, very different than React, but it does have you know, some form of lifecycle methods as your data model changes, updating the DOM. And then, yeah, again, that's the abstracted DOM manipulation, is as you change your data, the library handles updating the DOM for you. Cool, so wanted to kind of, I apologize for the busyness of this chart. But I wanted to compare and contrast a few of the different approaches and how to use these two libraries together. So starting off, like, you know, just looking at this top table here, I'm really just comparing or switching off between two things, which is which library we're using for rendering to the DOM, and then what kind of HTML elements we're using. So starting with HTML elements, like the two most common ways to render visualizations to the DOM in the browser is via SVG elements or canvas elements. So, you know, SVG elements, if you were to like literally inspect them in the DOM, you could see the individual elements. You could see, you know, it has its own, you know, syntax. There's circles and paths and rectangles and things like that. They're different than HTML elements, but you can actually see them in the DOM. Whereas Canvas is literally just like a painting, right, that you paint to, and you have your context, and you know, you draw a little painting, so you can inspect it later on. That's like the main difference when it comes to visualizations for SVGs versus Canvas. Calculations, what I'm talking about here is like actually calculating the like the path of if you have a bar chart, like the X and Y location, and then the height and width of each of the bars. Like really, you're going to always be using D3 because that's what it's made for. And then rendering to the DOM. So this is what we were talking about before, Dallas. It's like you can use either React to render to the DOM, or you can use D3 to render to the DOM. So yeah, you can do kind of like hacky things, like you can say, you know, React render this page initially, and like, you know, load up your D3 code into the browser, and then you can say component should update and then always return false. and then every time component should update, you can have D3, control the DOM. But it's like, it's a little bit hacky if you ask me. It's like, and it's also difficult to have two different conventions of, ways to control the DOM. So yeah, this is when we're kind of getting into like the pros and cons of each of these. Transitions, this is again, like changing things over time. And I'll show a live demonstration if it's not clear, like what a transition means, because it is like kind of like it's the stuff that makes you feel good about the visualization. It doesn't just happen abruptly, it like happens over time. And so for like you can see, like using D3, it makes it a lot easier for transitions, because if D3 is controlling the DOM and it's also doing the calculations, there's like if you follow the D3 conventions, it's a lot easier to do these more complex transitions. And so like I would give the thumbs up to D3 and the thumbs down to like using React to control the DOM in that case. For click events, I would give the thumbs up to SVG elements and the thumbs down to Canvas, because again, you have individual DOM elements, albeit SVG elements that you can tie into for SVG elements, but you can't do that for Canvas, if that makes sense, right? You can't, like, if you draw a visualization, and then if it's a bar chart, you have 4 bars. If you were doing it with SVG, you would have 4, rectangle SVG elements that you could tie click events to, or hover events, whatever. But if you're doing that with Canvas, it would all be a single element. So you could do some fancy stuff like on click, you could calculate the X and Y position of the click, and then, go back and do some, reverse engineering to figure out what element they actually meant to click on. But that's like, pretty tricky. Okay, so many elements. This is like why you would want to use Canvas. If you have visualizations with thousands or tens of thousands of individual elements, you can imagine weighing down the DOM with all of those SVG elements, compared to if you were just doing it with Canvas, it would just be a single element, regardless of how many nodes you have. Ease of use, I give the tip to React here. Let's see, yes. I don't really know. I got elements of thumbs down, but yeah. So like, really, my favorite approach is approach number 2. Transitions are like, they're really nice and they make visualizations feel good, but they're not 100% necessary, right? If you want to do like change the data model and have your visualization like be jerky and update over time, approach number 2 is beautiful. And then I would also say that like the many elements scenario is kind of an edge case. Like in most situations, you're not going to have tens of thousands of elements. You're going to have on the order of 10 to 100 elements, and that's like whatever the browser's going to have no problem. And then so there's things you can do. There's 5 things you can do. So I found this library. It's called React Move. It has a nice API that's pretty similar to the D3 lifecycle methods, which I'll go into later. But it allows you to do transitions a lot easier inside of React, and then follow the D3 conventions over transitions. And so when paired up with a library like React Move, I would almost always, maybe 90% of the time go with approach number 2. And then like in the unique situations that you hit one of the edge cases that I described, you can go with one of these other approaches. Cool. So this is just a little kind of stupid app that I wanted to build today. Pretty simple. It's just a shopping cart, and it'll show a donut chart. Disclaimer: like I'm not advocating for donut charts in particular. I have a friend who was like a data scientist at Google, and he told me once that there's never a single instance when you want to use a donut chart or a pie chart over a bar chart, like never one single instance. So I wouldn't go that far, but I would go as far as to say is like, yeah, they're not really that great. But for demonstration purposes, it's kind of an easy visualization to make. Anyway, disclaimer done. So yeah, so we'll build a little app that's like a little shopping cart. We can add items to your shopping cart and add the quantity. Oh, I don't have it on here, but I also want to be able to increment and decrement the quantity of each item in your cart, and also be able to remove it. So yeah, this is what we're gonna be building. Let's build it. Okay, so now we're getting into just like general approach of like how to build something like this. Okay, so research, find a D3 example. Okay, let's do that. So I literally went to the Blocks website and I scrolled around until I found like a donut chart. I don't think this was the one, so I have it bookmarked here. Yeah, so this is the one that I kind of reverse engineered. So yeah, this is like, you know, whatever. It has a lot of good examples. One of the things I also check is the version of D3. If you start playing around with D3, you'll notice that the API changed pretty significantly from V3 to V4. So when I'm looking for an example to build a visualization, I'll like first check the version here, and you can see that it's V4, which I'm also using in the example app. So yeah, so that's like I would check. And then, you know, here is like the data loading helper going down. Yeah, whatever. Step number 1 complete. find a good D3 example. Step number 2 is I'd separate the logic in that example into 3 categories, which are the calculations, like how are we turning our data model into something that can then be turned into our visualization, right? And, you know, what I mean by that is how are we calculating, you know, the start angle, end angle, inner radius, outer radius of each of these elements. The DOM manipulation. So like in this example, we're most likely, in this example, you know, it's all like raw D3. So that's the part that we're going to want to like see how it works, but then like not use, because we're going to be using React and React Move for building this donut chart. And then transitions, again, like see how they did it, but we're not going to be using the exact same thing because we're not going to be using D3 for transitions. We're going to be using React Move for transitions specifically. Make a plan. So define the scope. Like, what do we want our MVP of this little app to do? We want to be able to add an item to the cart, increment and decrement quantity of items, and remove items from the cart. Also, I didn't have it here, but it's like also have the donut chart reflect what's being displayed in the table. And then lay out a technical plan. Like, how are we going to create our data model? How are we going to create our view model? And then how are we going to do transitions? It's like always an important thing to think about. Finally, we're going to create it. So step 1 is like, let's just create the table. Let's be able to have an input for the item and then the quantity of items and be able to add it to a table. For that, we're just going to be using just React. Then we'll work on the donut chart. So that's when D3 will come into play. And then finally, we'll do the donut chart with transitions. So we'll use React for the table, and all the DOM manipulation. We'll use D3 for the calculations, and again, React Move for calculating the transitions and updating the DOM over time. Cool. So this was the same Venn diagram that I showed before, but just wanted to be explicit. Okay, so where D3 and React can both have the abstracted DOM manipulation and the lifecycle methods, we're going to be leaning on React to do both of these. Also, we're not going to be doing any explicit DOM manipulation. So really, D3 is going to be used for its visualization helpers. Also, if we wanted to load some data from, for example, a CSV file, we'd like lean on D3 for that. To the code. Okay, so yeah, how you guys doing back there? Can you see this all right? Okay, let's actually like check out a working version of this app first. Cool. So this is the app that we're going to build. You can see what happened there with like, so those are the transitions that are happening over time, right? You can imagine if this was just being loaded immediately, you wouldn't have that nice kind of fanning out. You can also see that I chose to have random colors for each of the elements every time. That was just ease of engineering. And then let's kind of like play around with it. So what do you guys want to add to our cart?
Coconut.
Coconut. How many?
5.
5 of them. Cool. And unfortunately, it has a very similar color to apples or oranges. So yeah, and then we can like change the quantity of each of these items and see that reflect. Again, you know, this isn't a quality app. I wouldn't put this in production. There's things missing, like I would obviously want labels, and you know the transitions are a little bit goofy, but they're for demonstration purposes. And then you can also like take things out of the DOM, right? And it has that nice transition where it closes shut. So let's see. I wonder how this will work. If I don't want to show side by side, but I feel like then I won't be able to blow it up big enough. So yeah, so you saw the final version. So let's just start off by building this little bit right here, right? Let's be able to add items to the cart, you know, increment and decrement items. This is like, you know, web development 101 here, so nothing crazy. So, you know, we're importing React. Find index by name. I guess we'll check out later why we made that. We're creating our app right here. It's all going to be in one component, just for demonstration purposes. Populating some seed data. So you know, we have initially 3 items in our cart. Each has a name and a quantity. And then we're, you know, creating our state from, you know, we have our data from our init data, and then we're initializing our form to also be some empty strings. And then we have some event helpers, increment item, which is just going to take a name, find the index by the name. So that's why find item index by name. So this takes a name and items and returns the item index. So now I have the item index. If I'm searching for banana, I'll get 1 out of there. And then find the new item, or sorry, create a new item, which is going to be the old data. Oh, sorry, yeah. This is increment item. So this is if we want to increment the quantity of bananas. So we're gonna, you know, pull in the old banana data and then add 1 to the data, and then create a new array of data. Pretty simple, and then set the new state. Decrement item does the exact same thing, except instead of quantity +1, it'll be quantity -1. Cool. Remove item is just you know, slicing out the current item by index. And add item, again, is, let's see, creating a new item, which is right here, and then essentially pushing it to the end of our array and sending that to data. Handle change to actually use it. Okay. Oh yeah, so this is handle like form change. So this is pulling the old form from state, creating copy of it, and then updating the new value of that form field. And then this is just doing some destructuring, and then putting out, let's see, here's our input right here. Input, and then we have a button to, you know, add our item right here, and then we're mapping over our array of data and just tying in some, binding some click events to each of those buttons. Cool. So again, nothing crazy. Yeah. Any questions? We all good? Cool. So yeah. So that was like step number 1 that we talked about. Like back here. So next, like working on like building the donut chart, like actually getting some data visualization involved. Cool. So not going to do any live coding, but we can just see the difference between branch 1 and branch 2. Branch 1 is just, what we saw before, just that bare bones React app to render the table. And then branch 2 is the exact same thing, but just with the donut chart minus the transitions. Cool. So if we check out branch 2, and so now you can see what happens is it's a little bit more jerky, right? It still works. The colors are random, but it still works. But it doesn't have the same feel to that first app we had when it had all the nice transitions, right? And so you can remove it, and it all happens kind of instantaneously. So if all you care about is rendering your visualization to the page, if maybe there's not going to be that much user interaction with it, and you just want to load a visualization from some backend, this may be sufficient if you're not going to be doing any crazy transitions. In which case, the front end logic is much simpler. So yeah, we're just checking out the difference right now between branch 1 and branch 2. So this is just what was added in order to create this donut chart right here. So just creating some high-level variables to define the dimensions of this chart right here. So our view is 510 by 510. We'll have 10 pixel margins. And then these are just our dimensions, our X dimension and our Y dimension. Just doing a little bit of calculations. And then also calculating the radius of our donut chart. Let's see here. Okay, so this is when D3 comes into play. We have D3 helper methods. You can see we imported arc and pi from D3. So this is pi layout is pi, and then dot value, and this is D3 will map over each of the values in your array of objects, and then this is specifying what the key index is to create your pi dimensions from, and then we're not going to worry about D3 sorting this. And then the arc path. So this is if we inspect one of these, you can see this is our arc path right here. So again, you guys feel pretty good about SVG elements and translating this D attribute into what you see over here on the left. Thumbs up, thumbs down. Yeah. There's some tools that we can go to if you guys want to check it out. I have one bookmark. Let's see here. SVG path parser, that was the one. So if I
make it larger.
Yeah. Let's see. That's how you do it. Okay, yeah. So this is kind of the individual commands that are being communicated to D3 in this path element. So we have an array of 5 items. The first one is M, so it's move to. So move to, these dimensions, X and Y, and then create an elliptical arc, right? So you can see these are just a set of instructions to tell the browser how to create that SVG path. So again, no magic. This is just this is all we really need D3 for, is creating this this attribute right here. And that's what this arc path is doing for us. So the things that we need to tell D3 are the inner radius. So we're just going to say it's 40% of the radius, and the outer radius is 100% of the radius. Cool. Other helper methods?
So this
yeah.
chart is SVG?
Yeah. So this is SVG here. You can see the outer SVG attribute starts here. If this were canvas, again, you wouldn't see any elements inside of the canvas. You'd just see the canvas.
Pretty much we're drawing our SVG in browser.
Yeah, exactly. And you can see I'll fast forward a little bit, but you know, React is just going to create an outer, oh, that's our cart. So it's going to create an outer SVG element, and then a group to do a little bit of translation, and then it's going to map over our cart, right? And just spit out a bunch of calculated SVG elements, which are paths. The paths are just like a general SVG attribute to do like kind of an amorphous shape. It allows you to do, you know, these different commands, like follow this path, right? And then like there's one that's, the last one was like close it off. Anyway. Okay, so we're checking out the code. So yeah, this is where we're like defining the path attributes. I should also say, like, a little disclaimer, like, I don't know any of this stuff, right? This is all stuff that I took from an example. And I think that's pretty much how the D3 community works. It's like nobody really invents this kind of stuff anymore. They just look at other examples of other people who have done it and then, you know, figure out how to best work in your app, right? So I don't know the full like Pi API or the Arc API, right? I'll sometimes go to the D3 docs. Honestly, they're not fantastic. They don't usually have a ton of examples, but I'll usually go to the Blocks website and just see how somebody else did it, especially Mike Bostock, because he's amazing. And then, you know, recreate that for my specific application. Generate random color. This is when I'm just, you know, using a random seed to create these random colors that I'll use for each of the SVG elements. Again, you can see, like, you know, if it's not green, it's what you saw before. So I'm just adding an attribute to each element of my initial data. That's just the color. And I'm going to kind of keep two arrays in my state, one of which is just the original data, the unmanipulated data, and the other is this D3 manipulated data. So if we go over here and we check out our React Dev Tools, yeah, you can see we have like cart and we have data. And if we want to inspect it, they're both like, you know, array length 2. If we added something to this, you know, they would both be array length 3. It's just that data is like the raw data and cart was the D3 manipulated data, right? So we can kind of inspect how they look a little bit different. This is going to look familiar. So we have a color, a name, and a quantity. So these are the things that D3 calculated for us. Can you guys see that in the back? Try it. How's that? Sweet. So yeah, so we have like start angle, end angle, index pad angle would be, you know, if we wanted a gap in between each of our slices. The value, like the original value that kind of determined all these other values. And then here in data, one level deeper, we have like the unmanipulated data that D3 used to make all these calculations. Does that make sense? Like the difference between like cart and data right now? Okay, cool. Can I get some thumbs up? Yeah, sweet. So this might not be the best application design, right? But I'm trying to at least demonstrate the difference between like your unmanipulated data and then like what D3 outputs. Cool. So that's like, yeah, that's using Pi layout right there, which we defined up here. We still haven't used ArcPath. So we use that a little bit later on when we're on our JSX and actually specifying what we're going to render to the DOM. So again, see, decrement item, no change except we want to recalculate the new Pi layout because we just changed the value of one of the slices. And you can imagine, like, even if you change just the slice of this one, that's the one with 4 right there, the bananas, the other 2 are also going to change, right? Because you're recalculating all of them. So you need to, you know, recalculate all three of them, not just the one. Remove item, again, same thing, recalculating the cart. Add item, you're just, doing the same thing, but generating a random color, and again, recalculating the cart. And then now we have an extra, like instead of mapping over data, we're gonna map over cart. Pretty similar. So this is what we're using to create the table again. So again, we could have mapped over data. I'm just mapping over cart and going one level deeper into data because it still lives one level deeper in this like data object. And then finally, like this is when we actually turn our data model into something that the browsers can understand and turn into path elements. So we're creating an SVG element. We're using our dimensions array that we created up above to define the outer dimensions of the SVG element. We're using some clever translations to get the donut chart centered on the SVG, and then we're mapping over the cart, right? And so we can just explicitly tell React what the fill color will be, and then give it some key. This is when we use the arc path that we defined up above. This was another one of the D3 created helper functions, and then we're mapping over each of these cart elements. How's that sound for everybody? Pretty good? Okay, now we're gonna do a little bit of the crazy stuff, which is the transitions. So I didn't do live coding because I can't even say git checkout master. Okay, cool. So now we're gonna add that like added cool effect of like transitioning things over time, which is really like this is really what makes like visualization really appealing to people, especially when there's a lot of like live user interaction that's happening. So before we compared 1 to 2, so now we're just going to compare 2 to 3, or 2 to master, I should say. So the things that we're adding for this these added transitions, we're pulling in the ease. I think this is exponent outs from D3, so I can show you like what the ease API looks like. It's just a bunch of like predefined functions that'll like I think the x-axis is pretty consistently like the unit, so 0 to 1, and then it'll output somewhere between 0 and 1 depending on like the time scale. So like that's maybe not the best explanation, but you can see what's happening. You can select these different D3 helper methods to change how things transition over time. And there's like plenty of them. These are all you can do the bounce back, things like that. Node group. So we're using React Move. So this is very tied to the React Move API, which when you're doing transitions, like there's probably a ton of different React transition libraries that you could use to do transitions over time. The reason I chose React Move was because it had a very simple API of being able to define start, enter, update, and you can also add a leave handler and then fire those callbacks when those events trigger. So yeah, again, all the same. I'm defining React Move methods. So now it gets a little complicated. So I just broke it down into some. So just to be like very explicit, what's happening here, we're creating like a raw array of objects using D3 to transition those to manipulate that data into also an array of objects, but just with some added D3 calculations involved. And then we're using React to render to the DOM, and then React Move to do this lifecycle here. And this is kind of what I wanted to show before. So right here where I have the React Move logo is kind of where we define those helper methods. So this start enter, update, and leave. So this is kind of what's happening with every element over time. So on start, React Move will fire the start helper function once, and then on enter will fire like very consistently. If you're entering over like a full second, it'll fire, every millisecond or multiple times per millisecond over that full second. So that's like what this first transition is happening, right? That's how we define that. So sorry to jump back and forth so much, but it's pretty important that that we understand like what these methods are actually doing. So if so start is like an instance, enter is happening over like some period of time. It's firing a bunch of times. So right now everything's happening over 2 seconds. So if I wanted to increase the duration over how those elements entered the DOM, and I wanted to make it 6 seconds, I could do it like that. Oh yeah, looks like I can't do it in this view. Let me jump over here. And then enter, I'll change this to 6,000. I'll save it, and that'll update. Now it takes 6 seconds. So this is when like the power of D3 really shines over those other libraries like Tableau and Charts.js and all that stuff. You really get like full control over how you want to do these customizations. So yeah, and like we could do the same for update. So update would be if an element's like calculation parameters have changed, but it's still in the DOM. So that's like when we're changing the quantity of one of these, right? So right now that happens over 2 seconds, right? If we wanted to make this 20 seconds, so enter, that's happening over 6 seconds. And now let's see, if we wanted to increase the quantity, oh, that's not going to show very much, but I guess that's hard to demonstrate. Yeah, okay, so a better one to demonstrate would be like leave, okay? So let's say leave takes 20 seconds, okay? We'll recompile that, and then we'll do like this big one down here, so that's the orange, and that's 6. So this should take like a really long time to leave the DOM. And that's a bad example because those are 2 similar colors. I'll refresh. But yeah, so let's try it again. So this green one will take like 20. So you see what's happening there? Is the purple one and the yellow one were only taking 2 seconds because they just needed to update, whereas the one that was leaving was taking 20 seconds. So what if the ones that updated took 10 seconds and the one that was leaving took 500 milliseconds? Okay. So this one, so now like that big one will zip away, and then those other ones will kind of like collapse around it. Now you have like full control over how you want to do these customizations. Okay, cool. So going back to like the diffing view. Yeah, so we just created these little helper functions here. Nothing new there. And this is just the React Move API. You wrap your node elements around a node group, which is provided by React Move. Provide the data that React Move is going to check and update over time. What are you going to key in on each of these elements, and then start, enter, update. And then I think looks like there's also a difference between this, because I think this one also defines a leave. Yeah, this one also defines a leave. That's okay. And then yeah, everything inside of here is the exact same. It's just now it's getting that information from React Move, which is doing those, like providing that information to React or to the DOM like over time, doing those nice transitions for you. Cool. Any questions about any of this stuff? Yeah.
So this is probably your first chart, library versus framework. You may have answered this, but D3 is mostly just providing you all these methods to calculate the angles and stuff, but you're rendering all the elements yourself every time. And is that just to get it into React? Or is that?
So yeah, the only thing we're using D3 for is the calculations for like the overall pie chart, and then for calculating like this specific path element, like D attribute. And then yeah, we're leaning on React and then React Move to do all of the DOM manipulation.
But it would be possible to do it with D3 alone.
So yeah, so this is what we were getting at before, is like you could do something like load the page and then, you know, use D3 to like render the initial page to the DOM. And then whenever your data model, and then you can use React to manage your data model. And then whenever your data model updates and React wants to re-render the component, you can say component should update false, and then put all your D3 code inside of component should update.
Like
and then,
you said in the beginning.
yeah, but it's like, it's a little bit hacky. I'm like, look how beautiful this is. Yeah, over. Cool. Anything else?
Would you do the same with jQuery?
You could, like, what would you want to lean on?
Just transitions.
You would use jQuery for the transitions.
Yeah.
Would you use it in conjunction with React?
Yeah. So like instead of using this third library.
React Move, yeah.
Yeah.
Yeah, I think I just leaned on React Move because it's, you know, written in React, and the API is also pretty similar to D3, where you have these update, enter, start, enter, update, and leave methods, where it's like this is an API, and you can almost like reverse engineer the D3 code that you looked at from the example, and then like recreate that in your React Move helper functions here. But yeah,
How do you decide when you build your project and you, for example, you have this new task, you have to make transitions. How do you pick the tool for that? Like, what's your logic?
Yeah, there's no silver bullet. The React Move, I don't think is a super well-established library, so I don't know if I'd, you know, go ahead and say like, yeah, I fully endorse this library. I worked at a previous company where we did do the little hacky where you say, you know, React component should update false, and then do all your React code in there, because D3 does have, you know, really powerful transition methods. But yeah, it's like sorry, it's going to be an unsatisfying answer, but there is no silver bullet. In this case, React Move worked great for me. But yeah, I don't think there's one solution fits all.
So you just search, like you do Google search, or?
Yeah, I mean, I for this, like, you know, trivial example, I went through a couple libraries. This was a couple weeks ago. React Move was the one that I landed on. But I tried React Transition Group. I don't know if you guys have any experience with that. I think I moved on from that pretty quickly. And then there was some other like third-party libraries that were more well-established than React Move. I ended up landing on React Move because it was such a simple API. It was just like, provided those 4 methods and, you know, feed it these little parameters and it'll just work. Yeah. Cool. So, so that's really it. I just wanted to, reiterate. I hope you all are able to answer these questions now of, like, you know, what's data visualization? How does it fit? How does D3 fit into the ecosystem? What you can build with it. You know, definitely check out that Blocks website. There's like really, really awesome stuff you can build with it. How does it work with React? You know, there's kind of just like a ... because there's a lot of different ways to do it with React. This is just one of the different approaches, but again, there's many. How should you approach a problem? You know, I think there isn't super established protocols. I showed you the way that I do it is just go to the Blocks website and try to reverse engineer how somebody else did it, and then how to best fit it into your own application. And then, yeah, stretch goal. I hope you all really enjoyed D3. I hope you all really enjoyed this talk. Do you have any more questions?
One last quick question. Can you show this Blocks website?
Yeah, absolutely. Anything in particular?
So blocks.org.
Oh yeah, bl.ocks.org. If you Google like D3 blocks, it's the first one that'll come up. In the back.
So, where do you start hitting like performance issues? Like if I want to put like 500 SVGs into an array, is that going to be pretty easy, or is that going to start pushing the envelope?
I'd say I'll answer that question without transitions. Like 500, no problem. 1,000, 2,000, like yeah, that's when you're going to start hitting performance.
The transitions is going to cause the recalculation.
Yeah,
it's
so
the one-off. Basically, forget it's easy.
Yeah. If it's just like sitting on the DOM, it's not going to be too bad. It's like the transitions that really weigh it down. You can see like if we want to inspect one of these elements, and like I'll change just the banana and see like how many times that recalculates over time. And just imagine multiplying that by 50 or 100 or 500. That'd be it gets pretty ridiculous. Anybody else? Cool. Thanks, guys.
Sorry, one more.
Oh yeah.
So in a real application,
yeah,
you wouldn't have the two arrays, right? You would just map it in and do it on the fly, or
I would not do it. It's duplication of data, but it's also separation of concerns. You have your raw data constantly, and then that's your source of truth. And then you're just using D3 to like turn that raw array of objects into like its D3 manipulated array of objects. So like while they both sit in state, like I still kind of like this approach of like having two parallel arrays. But yeah, like you could probably make it work with like, a true single source of truth.
The idea of just using D3, if you didn't have React or D3 instead of React, you wouldn't care about that data. D3 would just handle all of that.
Yeah.
But because you are using React to handle those transitions and everything, you have to pull that data out of D3 essentially.
100%. Yeah, exactly. So if we want to like inspect like what a typical D3 life cycle looks like, you'll see a lot of just chained methods. So here's like the meat of it. D3 select bodies. Let me pull that up. Select all of elements with the pi class. And then this is when we're selecting the data. And then there's, this is the enter, so parallels to React Move. We're going to append SVG elements, and each of those SVG elements will get a class. And then each of those, I'm not sure what multiple is doing. But, in the same vein, you could just continue this chain, and there's a dot transition helper, and then you would do dot, I haven't done it in a while, but you would specify, the D3 ease method that you would want to use to calculate that transition, and then also like the duration and all the arguments that go into it. So it's just like this big chaining of methods. Very different than how you do it in React. Hey, you have a question over here?
Too complicated.
Okay, sounds good. We can talk after. Cool. Well, thanks again, guys.
Thank you.
All right. Thanks everyone for coming. We're the first Monday of every month, so hopefully we'll see you guys again. And feel free to take some of this pizza home with you. We've got plenty. So have another beer. But yeah, thanks again, Luke. See ya.
Thanks.